our focus is going to first be on the compound inequalities. And the reality is, it's just really two inequality statements combined as one. So compound meaning we're going to join them together. So there's two different ways that we can join inequalities together, and I'm going to show you both. So there are two types of compound inequalities. There are what we call ands, so that's one group, the ands, and then the other group are the ors. So when we're dealing with compound inequalities, they fall into one of those two categories, either an and or an or. And I'll show you how to recognize them. It's actually pretty simple. But just know that you need to throw them into those categories of either and or. Here are some examples of ands. There's noticeable features so that you can tell exactly whether or not it's an and. In the simplest cases, you literally have the word and in the sentence joining two separate inequalities together. The other case is where you've actually written them together. So notice with the multiple inequality symbols, this really means 2 less than x or x greater than 2 and x is less than 6. So I've combined two inequalities together in one sentence. Same thing down here. And you'll always notice that the variable tends to be in the middle, and then we've got numbers on either side. So that's typically the form. These are the forms that you will see an and come in. I'm going to retract that statement. Sometimes the variables won't be in the middle, exclusively in the middle. There can be variables on either side and in the middle, or just on the outsides. So just look for the two inequality symbols together, and you'll typically have three parts: the left, the middle, and the right. So you'll get in the habit of being able to recognize when it's an and versus when it's an or. And you'll see why in a second. Ors, on the other hand, are much more straightforward. They only come in one variety. The word or is going to be there, and it's going to be two separate statements, two separate inequalities separated by the word or. So those are going to be easy to identify. The key to solving a compound inequality is really understanding what to do when you're solving a regular inequality. The trick is there's just two of them. So at the end of the day, in most cases, you're going to have to solve multiple inequalities just like we did before. You're going to graph them, and then you're going to end up with a solution set. So the concepts that we learn for just standard regular inequalities applies here. We're just going to be doing multiple inequalities, sometimes at the same time or sequentially. It's kind of up to you. So here's our first example, and I'm going to show you two different ways that you can set this up, and then I'm going to have you solve it. Notice here, most of the directions are going to say solve, and then it's also going to say graph. So yeah, let me show you two different ways that you can set these up, and then at the end of the day, you're going to go ahead and solve them yourself. So the first method is to actually separate these into two separate inequalities, and then write the word and in between, and then solve each of them. So let me show you the setup for that. So it would just look like this. Okay, I basically, on the left side, I ignore the less than 19, and that's my one inequality. Then I put the word and in between, and then I ignore the left side, and I drop the other one in there. That's really all there is to it. Solve each of them, graph, and you're done. And the graphing with compound inequalities is a little different as well, but I'm going to show you that as well. So let's focus now. You don't have to solve this yet, because I want you to make a decision after I show you the second method on which one you want to solve. So let me show you method 2 now. So method 2 is to actually solve both of them together simultaneously. Okay, understanding that the steps in order to solve those inequalities are going to be the same. You just have to go through it twice. So in reality, what we're going to be doing is add 2 to both sides and then divide by 3, solving those inequalities. You're just going to have to do that to each side. So this is where I'm saying you do both at the same time. The key is focusing on this 3y minus 2. Add 2 to both sides, divide by 3 to both sides. So this one is a little more sophisticated. This one is for somebody whose confidence is pretty high. And I feel like many of you could probably get away with this. So at this point, what I want you to do is make a decision. Do you want to do it this way and try it? Maybe the first go, you do it with them separate and you do 2 separate inequalities just to be sure. Okay? And then maybe after that, you do them simultaneously. Make sure you get the same answer. So this is the part that I'm going to kind of leave up to you. I'm not going to tell you which one you have to do. You should know at this point how confident you are in your equation solving strategies and abilities. After the work that I've been looking at, some of you are doing guess and check and are not undoing inequalities or equations. If you're in that boat, you should use method 1. You've got to really get good at solving inequalities and equations the right way. Those of you who already know, add 2 divided by 3, and it's just sort of second nature to you, you might go over here and try that. So, long story short, solve it. You pick. After you're done solving, go ahead and start the video back up. So go ahead and pause it, solve it, and then start back up. So I've been kind enough to come up with both solutions, whether you use method 1 or method 2. Okay. Notice my answers are the same. Okay. So if you need to pause it and analyze your work and compare it to mine, do that. Here's the thing. With ands, we will typically rewrite our solution. Instead of putting an and following it down all the way, we will write it as that compound inequality again. Over here, added 2 to both sides, so I did it to both sides, 21, 12, then divided both by 3. I automatically still have both inequality symbols and they're joined together in a compound way. So either way, you should end up at the same answer, and hopefully you did. If you did not, pause, rewind, check your work, compare. Where did you go wrong? Where did you mess up? And if you don't understand where your mess up is, write that down as a question and be ready to come ask me those questions during class. So the next step, of course, is to graph. And keep in mind, we have 2 inequalities, which means we sort of are going to have 2 graphs. And I'm going to show you what I mean by sort of here in a second. So our first graph is this part right here, 4 less than or equal to y. Okay, the first inequality. And remember, when we talked about this the other day, you want to look at it from the perspective of y. So I flipped the whole thing around, so I know that it's actually greater than or equal to 4. It's all from the perspective of y. So that's going to be the first part of the graph. Now the second part of the graph is this part, the y less than 7. Okay, so notice I have the open circle. It's going to be going to the left because it's less than. Notice up here with the or equal to, I have the closed circle. The reality is what I have to do is join these 2 graphs together. And here's what that'll look like. So literally what you're going to do when you do these kinds of problems, you will put both of these individual inequalities on one number line like this. Now, for an and, basically the solution needs to be the intersection of those 2 lines. Okay? The intersection of those 2 lines, because the solutions for y have to have to satisfy both. It has to be greater than or equal to 4 and less than 7. So it has to be both of these. And the only place where y is greater than or equal to 4 and also less than 7 is right here in this section here, and it'll look like this. See what I did there? Yellow and blue make green. Fantastic. Okay, so here's the reality. This final graph down here is my actual solution set graph. All the values that are greater than or equal to 4 and are also less than 7 fall right in here. Now, when you're graphing on your in Notability, you can do what I did here and then really kind of shade this in. You can do a real light highlight for your original arrows and then darken it in with color. You have creative control over that. Just make sure it's very, very clear that your solution set is darkened in somehow. Here's what my final answer will actually look like. Okay, so my solution, and here's my solution, here's my graph. This would be my final answer. Okay, all those steps that I showed you leading up to that, those are things you're going to need to do. You'll start doing them faster than the way I did. Obviously, I'm trying to show you what to do for the first time, and then after that, it becomes quicker and easier, and you will find tricks, you will find methods that will allow you to do them more quickly, okay? And I encourage you to explore those. Okay, let's talk about ors, and not the kind we're talking about in a boat. We're talking about the or compound inequality. So I'm giving you a real easy one here. Bottom line again, you're going to be able to recognize an or because you're always going to see the word or. If there is not the word or, it is not an or, okay? There is no option with ors to solve them simultaneously like there were with ands. When we had the two methods with ands, the possibility to use one of the two methods, I should say. With ors, there's none. There's one method, you got to solve them separately, end of discussion, okay? So the reality is a compounding inequality, that's an or. It's really two problems, you solve them, and you're good to go. So, pause, solve these, and if you even want to go ahead and graph, go for it. Same deal, you're going to graph them, one solution set, they're going to be on the same number line. Like we put the ands on the same number line, you're going to put the ors on the same number line. So go ahead and pause it, solve it, and then when you think you're done, come back to the video, and let's see if you did it right. So here's what you should have gotten. X less than negative 8 or x greater than or equal to 3. Notice here, this inequality flipped. You had to divide by a negative, so this should have flipped over. Hopefully you did that. This one, subtract 8 from both sides, good shape. Okay, then of course we need to graph. And basically you're going to graph this and this on the same number line. Correction, you should have subtracted 5 from both sides, not 8 from both sides. But hopefully you were able to make that correction in your head without me having to make it for you. So this is right. I said it wrong the first time. So here's what it should look like. Let's see, we've got right over here, the greater than or equal to 3, the less than negative 8. And here's the great thing. Most of the time, when you have an or, they're going to have arrows going in separate directions with space in between. Because you can either be here or here. You can't be in both places. That's why it's an or. If this was an and, if you had an and the graph looked like this, the answer would actually be no solution, because there's no way to be here and here at the same time. On the ands, you're looking for that intersection. Here, there's no intersection. So, got to be careful on those. If it's an or, your graph should typically look like this. If it doesn't, we'll talk about that scenario later. If this is an and your graph looks like this, you have a problem. Well, not really. There's just no solution. So you want to really double, triple check that to make sure you did that right. Hopefully you got both of these okay. and we'll be in good shape to start talking about absolute value inequalities. So here's the thing. So we've talked about ands. We've talked about ors. Absolute value inequalities are exactly the same thing. Okay? They are compound inequalities in disguise. And you'll see what I mean here in a second. Absolute value inequalities are ands or ors. You just have to be able to figure out which one is which. And thankfully for you, I'm here for you. So I'm going to help you do that. So here's the key. With absolute value inequalities, we want that absolute value by itself on the left-hand side. This time I really want to force that idea. The concept of getting the absolute value by itself first is still in play, like when we were doing absolute value equations. You need the absolute value by itself first. Yelling, screaming at you, please don't do anything until you do that kind of thing. Let's get it on the left side. And bottom line is, once it's on the left side, less than or equal to are ands. And somebody along the way taught me less than. So than, less than. So that's how you kind of remember. Because the other one is greater, or. I'll show you that one. Here you go. Absolute value again by itself on the left-hand side. Greater than, or greater than or equal to. Those are ors. If that helps you remember it, fantastic. Obviously, there's than in both greater than and less than. So I think really what you got to do is you really got to think about greater, and then the other one is and. Okay. However whatever method you need to use to keep it straight, I don't care. Whatever works for you, just keep it straight. Okay. Again, absolute value by itself, left-hand side. And so what happens is you take that absolute value, and then we do some similar things. There's one little twist, though. All right, again, simple example. The absolute value of the quantity y minus 5 is less than or equal to 2. The first question, of course, is this an and or an or? Answer, please. Literally say it out loud. What is it? Is it an and or? So I've got the absolute value on the left by itself. It is less than or equal to. It's not greater, it's less than. So this is an and. Now, it is an and. And so how we set up our two inequalities, because remember, an absolute value inequality is just really a compound inequality in disguise, which means there are two inequalities here. Okay, let's go through each one and how to write them. One of them's really easy, one of them's got a little twist to it. So the first inequality that you're going to write is really simple. It's simple because it's just like the absolute value equations. Okay, whether it's an and or an or, it doesn't matter. You set up the two inequalities the exact same way. The first one that you're going to do is basically drop the absolute value, and everything else is the same. So here's the first one. It looks just like this. There it is. Okay? Y minus 5 less than or equal to 2. Just dropped the absolute values. And then you're going to solve that. The second one is where the twist comes in. I'm going to make the explanation pop up in the bottom here so that I can leave space to solve my inequalities. But so the explanation should actually fall up in here first. But again, like I said, I want to leave space to solve the inequality. So here is the explanation for how you set up the second one. All right, ready for this? Here it comes. Second one's the problem without the absolute value symbols, except, here's the exception. You flip the inequality symbol, and then you change the sign of all of the terms on the right side of the problem, okay? So again, there's two pieces, two twists of the second inequality, okay? Change the inequality symbol and change the signs of the terms on the right. Here's what that would look like. Okay. So notice what I did. Still y minus 5. Just drop the absolute value. Now, flip that to greater than or equal to. Made the 2 negative. All right. And don't forget, this is an and. Don't forget to leave that. Be sure to include that in. Okay. So we have our two inequalities. Again, remember, absolute value inequalities are compound inequalities in disguise. That's why they are included together in this section. Go ahead and solve this, graph this, pause the video, take the time to do that, and then we'll come back and see if you got the right answer. So here's what you should have gotten. Y less than or equal to 7 and y greater than or equal to 3. Now keep in mind, whenever we write and solutions, we want to actually combine them as a compound inequality. And since it's an and, we can do that. Here's how we do that. I always like to write the smaller number first and the bigger number second. So that way it sort of follows the natural progression on a number line. So I'm thinking about number lines because I know I'm going to have to graph. So that's why I like to do it like that. And here's what it would look like when I combine these two together into one inequality, one compound inequality. Okay? So I put the smaller number first. Notice it is still pointing at the 3. Y is greater than it. So it appears that I flipped it over. I flipped the inequality sign. But because I actually changed the position of y and 3, I maintain that consistency. Y less or greater than or equal to 3. If I'm looking at it this direction, y greater than or equal to 3. This one stays the same, obviously, and we're good. So here is my compound inequality. Now all I have to do is graph it. So in this case, I'm actually going to draw it by hand so you can get a feel for how you can graph an and in one step. Meaning, instead of drawing two arrows and figuring out where they intersect, I can already do that in one move. All right? Because of the and, it's basically saying it's from 3 to 7. That intersection from 3 to 7. So if I were to actually graph it greater than or equal to 3 and less than or equal to 7, they would intersect. And I'll show you both. So if you want to get in the habit of drawing both, that's fine. I'm filling the dot in, and I'm going, because it's greater than, I'm going that way. And then less than 7, it's going that way. So the intersection is right here. Okay. Now, if we can get to a point where you understand that this is going to be the intersection of those two lines, and it actually ends up serving as an interval. Here's what I mean by that. So, because I know that this serves as an interval from 3 to 7 inclusive, because I say inclusive because that means you fill the dot in, so I can make a dot at 3, a point at 3, a point at 7, and know that the intersection is going to take place. I can literally just do it that way instead. You don't have to draw both lines and like I did above here and then fill in this part. You can literally just go to this. And so when you're starting to get good at it and you see that in fact it lines up the way it's supposed to, this can be your graph. Okay? So here you go, that's it. Compound inequalities, absolute value inequalities. Couple little things. Understand the basis is solving just regular inequalities. Just happens that maybe I'm combining two of them together. The concept of and or is in there. The concept of absolute value inequality and trying to identify which one is and or. But your foundational elements of this lesson took place a couple sections ago. Okay? In class, we will do the homework. If you have questions, come with those to class, and I will do my best to work with you and answer those, and we'll go from there.